Hello, and you're very welcome back to I think it's the fourth series of the technical videos on Formula One parts. Um, I'd intended, as mentioned, of doing them a bit sooner than this, but because of COVID, and even though I hate that word, but just with COVID and work and delays, um, the last few months have been mental, as you can probably imagine. If you're involved in the industry yourself, you can probably tell getting parts is pretty hard this weather. Um, and again, deliveries and all that stuff, it's very effective. But we're here anyways, so I'm going to do another video. So on this video, I'm going to be covering the Formula One oil tank, which might seem a bit boring, but it's actually very interesting. So what I've done is I set the camera up. It's a bit higher than normal. So I'm going to do just an overview first of the part itself, which is there on the left on your screen. It's a carbon fiber oil tank. What I'll do now is I'll just draw out where it sits roughly on the Formula One car, where it is, and I'll bring down the phone then, and we'll get some closer shots. So what I'm going to do now is I'm going to move down towards I've it left on paper there, as you can see. I'm going to move down and just draw out where it sits on the car and where the engine is and what's going on. I'll try not to get in the way, but hopefully we'll get through it all right. Now the video might be split into like 3 or 4 parts, and I'll edit it just for smoothness. But yeah, so we'll dive in and we'll have a chat. So as I said, on the left, that's the oil tank. It's approximately what to be about 550 mil high. In terms of width, then this way it's roughly about 150 mil. Now in terms of capacity, I don't know what it is. It's probably, I don't know, let's say 7 liters. But we'll get into that after a while. So what I'm going to do first is I'm going to draw out where the engine sits, the driver, all that, just so you know where it is. So I'll do that now. So the tank, as mentioned, is forward of the engine. So hopefully I don't get in the way when I'm doing this. The engine will be here. This is off a Honda V8. So don't ask me what year that is, but as I said before, I just know engines, not drivers or years or anything like that. So the rough outline of the engine will be here. The oil pump will be sitting here in the front like this. They're your 2 gears, the oil pump gears. They'll be driven off the front timing housing, which will be here, all the gears in there. The crankshaft level would be roughly here, with the weights and all that. Let's just show in for them, like so. Hope you can see over there. And the pistons then would be roughly about this level, offset to the journals. They're not in the same journal, so they'd be like that. Again, down here very quickly, very roughly. So they're the pistons, and the conrods down here then. And your cylinder headline will be here. Your head will be about there. And the trumpets then will be here. I won't draw them all in, but you get the idea. And your injector rail then will be here on top, spraying in here and here and here. There'll be another one there, another one there, another one there. So all your valve train crack would be here, your valves and all that, whatever. And the cylinder head breathers then, which will be off here, which we'll talk about shortly. And fuel tank, hopefully you can see this. You should be able to see most of it. Fuel tank will be here behind the driver. Driver will sit there. Hopefully you can see his head. I see my line here, the maximum line of the camera, but that's the driver there. That's his head. Fuel tank. So you can see where the oil tank sits. This would be where's my line here? This would be the rear wing of the car here. So the car will be going that way. So that's basically where it is. Sits in a very tight space in the bulkhead, just between the engine and the fuel tank and the driver. Alright, so that should give you a basic overview of where the part is. So what I'm going to do is now I'm going to pause the video and we'll see from there. We'll delve inside. All right. All right. So I got the camera moved down slightly now, just to explain why a Formula One car is different to a normal, like a road car, and why it's got a tank. So in a road car, let's say this is the engine in the road car. That's your car's going that way, your front wheel, and that's your rear wheel. I'll be back here a bit. So that's your normal engine. So normally it's got an oil filler here. You put in your oil, it flows down here, and it's got a sump, as you know, right here. Okay, so you pour in the oil, and the oil collects here in the sump. So that's the reservoir. And the engine then has got a pump, an oil pump, which picks up the oil from the sump, like this, into an oil pump, and it pumps it all around the engine, into the crankshaft, and up here, into the camshaft. And then when it does all that, when it lubricates the crankshaft and the camshaft, all the oil passes through the journals, drops down again, and oil collects. The oil collects here in the pan, and it keeps getting pumped around and around and around like that. And obviously there'll be a filter here as well on the side of the engine, to filter the oil going around. Now, that's your normal road car engine, but the problem with this is your crankshaft is here and it's spinning around here at high speed. Now, because all this oil is flowing down here past the crankshaft, and it's in the sump here as well, actually the sump would be like more so like this, the crankshaft will actually pick up the oil from the sump and start whirling it around, and that's called windage. And all this sloshing of oil and windage, and when you brake, the engine will go like this. If you brake like that, let's say you have -1G, like this way and this way, the oil would try to go that way, and it would flood the crankshaft with oil, which would crash into the crankshaft basically, which slows it down. So that's not good, and there'd be a lot of sloshing and all that. And I'll just turn it back again. So that's not ideal. All that takes a lot of horsepower for this crankshaft to be crashing through all that oil that's sloshing around and all that. So in a Formula One car, it's different. It's called a dry. This is called a wet sump. All right. So this is wet. This is a wet sump system. Now a dry sump system is like this. That's the Formula One engine again. The oil is pumped in from the pump here at the front into the crankshaft, up into the camshafts, everything else that needs it. And instead of having a sump, it's got a very shallow pan, which is called a dry sump pan. So once the oil comes through everything, all the journals like that, it collects here, very shallow pump or very shallow pan, and it's pumped out of that pan with what's called a scavenge pump. Now that's the side view. In view, the engine would look like this. Hopefully you can see that. I'll just have a look. Yeah, you can. So the engine would be like this. So that's your piston, conrod. Actually, it'll look like this. Conrod, cylinder head, and the pan at the bottom. And at the side here is a scavenge pump. So the oil will collect here. There's no reservoir like here at all for the crank to be sloshing through. There's nothing here. It drains from here and it gets sucked out of the scavenge pump and pumped back into the tank, which you'll be looking at in a moment. So in a nutshell, that's your road car engine. Lots of slosh, lots of mist, oil mist, all that, slowing down the crankshaft. In this one, there's nothing. As soon as it drops here, it gets sucked out here into the scavenge and pumped back into the tank through the filter, obviously. And then it gets separated here because there's very high velocity here. The oil gets mixed gets mixed with air and oil, and it gets very aerated. So what this scavenge pump does is it sucks it out of the sump, it deaerates it, which we'll cover in a moment, and it pumps it back into the tank. It drops down into the bottom of the tank, collects here, let's say this is the oil level, collects here, and then gets pumped back into the engine, into the oil pump, and way through the engine again. So that's very basically how it works, or the differences between a wet sump and a dry sump. There would be an oil cooler here as well on this line, but that's irrelevant at the moment. So what I'll do is I'll bring back the tank again. We'll leave that aside for a moment. So I'll bring back the tank again, just for a moment, there. So as you can see, that's the tank. Now it's normally that way, but I'm turning it this way, just make it easier on the camera, so you can watch it in landscape mode. Now I bought this tank off a guy in the UK who is called Mark Scott. Mark and Amanda, they're a husband and wife team. I've been buying Formula 1 parts off them for probably, I don't know, 12 years, I'd say. It's an amazing company, very cheap Formula 1 parts, and this isn't a plug, but definitely you should check them out. If you're interested in Formula 1 parts, you should definitely check them out. So it's called Race to Finish. They're in the UK, and it's Mark Scott and Amanda, his wife, that runs it. I think I've bought probably every part off them, bar maybe one or two, but they're very, very cheap, and they have a huge selection of parts. Again, not an endorsement, not advertising, nothing like that. They're just very, very, very sound people. So when the tank arrived, obviously I'd never seen one before, as had no one else on the planet. Internally, I mean, outside, yeah, you get loads of pictures online on the internet what it looks like outside, but internally it was totally unknown. So what I did was, I was going to, initially I thought I'd cut it with the 4-inch grinder down along the side and down along the far side, but I thought perhaps, you know, there'd be I don't know, internal baffles and all that inside it, which the disc wouldn't be able to get through. So what I did was, in the end, I got out the hacksaw, the old reliable, and I started here and cut from here all the way down to here, just in the, as you're looking at it, I guess the x-axis, and it took about 2 hours and about 4 blades, because I went through a lot of stuff in the middle that I hadn't banked on. But the tank, as you can see there, is all cut into sections, but I've taped back. You can see the sellotape there, here. So what I'm going to do now is I'm going to cut the sellotape and reveal the innards of the tank, so you can see it as I did, and I can explain then what's inside or what's going on. Now the tank is carbon fiber, as I said. Unusually it's made, obviously Honda know better than I do, but it's made inside out. The shiny side of the tank is on the outside, which is unusual. Normally when you'd be making a high precision part, where you'd want the high precision areas, you'd make it the other way around, where the mold where you put the carbon would be inside, and the layup, you know, the rough unfinished carbon would be on the outside, where it wouldn't matter. But they didn't do it that way, but that's just the way it is. So just to flip it this way, this is where the oil pump, I guess you'd call it, connects to the tank. So you've got oil from here to here, or from here to here, and it comes out this way into the oil pump. So the oil pump takes from here. There's various things here, we'll get through them in a moment. The feeds back into the tank, very clever little hose management systems, where I don't know if you can see that there, where hoses rest against, and you can put a cable tie down there in the slots. Very clever, you know. Again here, a little standoff there for a hose. You should be able to see it there. You put your cable tie through the little slot there. Again, I mean, I'm designing parts all my life, and you design a part and you discover that it's, or an entire assembly, and you discover that it's, wow, it's, you know, way too heavy. and you've got to cut out a lot of weight and mass. And honestly, like, they've cut mass out of the smallest parts, you know, so everything counts. But just to recap, these are the mounts, where it would mount onto the engine. You know, rubber mounts. It just sits on dowel pins. It's bolted here as well at the top. You can probably see there. These are all titanium, very nice parts, O-rings and all that. You can see the finish on the titanium machine in there. Hopefully it'll focus. Yeah, there you go. So again, you know, a huge cost. They're 5-axis parts. That one is anyway. The dipstick would go in here where you check your level. There's a bit of, you can probably notice there's a bit of whiteness on the carbon. That's just where it got damp, where it got moisture into it. You can probably see it there. That's a telltale sign of moisture. Now, whether that's my fault or someone else's, I don't know, but that's how it is. Again, all titanium. Anything else on the far side? Not really. That's where it would mount into the bulkhead. It just sits on standoffs there on rubber bushings, stop vibration and all that. That's where the price was. I think it was, I can't remember what price it was, but it was very cheap. So as you can see, the construction is made with 3 parts. The outside tank, you have 1 part here, 1 part here, and a central part here, which we'll get into in a moment. Just before I open it, oh yeah, the drain is here. Hopefully that focuses. To drain the oil, you open that bolt, you open that nut, you put a bolt in there and slide hammer it out, and you can drain your oil from underneath. Again, this is very much at the bottom of the car, you know, at the plank. So nothing to spare basically. So what I'm going to do now is I'm going to start opening the tank as I cut it with the saw, and hopefully you can see what I saw when I did open it. So we'll have a go at that, at cutting the sellotape. And that's 1, 2, 3, 4. So as mentioned, when I was cutting this, I had no idea what to expect. Hopefully that'll stay together. So there you go. So that's what I saw first. They'll be up there like that. And like that. Perfect. So it was pretty crazy, as you can see. Obviously I knew there was going to be a cyclone inside to separate the oil. Once the oil, actually I'll just bring in this sheet again. I want to try and keep it so that you can see it. Let's take it there, yeah. See it there. Keep my head out of the way. So I'll go into this in more depth in a moment, but when you separate oil from air, you have to keep in mind that once the oil all gathers at the bottom of the Formula 1 engine, it's got an oil and an air mix. So that has to be all separated. So that's done with, it's sucked up first with a pump like this. I have one here. A pump like that, all right? So you've all seen these, hopefully. So this is just a common, what would I call it, positive displacement pump. It sucks in the oil here, pressurizes it, and it puts it out there. Now these can be in 2 modes. They can be positive displacement or they can be compression, which I'll get into in a moment. But this outputs the oil then from the dry sump, and it puts it into what's called a that's the pump, and that pumps it out then into a separator, which is called a centrifugal or a centrifuge or a centrifugal, depending on where you're from, or how you were taught. So that pumps it into a separator, which is basically a propeller like this. A simple enough device. So it pumps into the center of it, and that flings the air and oil moisture, or the air and oil mixture, out to the side. And the dense particles get thrown out to the side like that, which is the oil, and the air stays in the middle. So the air gets pumped out the middle, out there, and the oil then clings to the side, and it's taken off here, off the side. Hopefully you can see that. Can you? Yeah. So it's this exit here we're worried about, and that comes in here into the Cyclone. So that's coming in there at high speed, and it comes in there at high speed tangentially and swirls down like that. And what happens is that takes out the velocity of the oil. The oil clings to the side. It's probably easier showing this one. The oil clings to the side. You can see it comes in there at a tangent, swirls around, oil sticks to the side, runs down here, and the air separates and stays in the middle and goes up here. All right. So that's the first separator, the last separator, should I say, the Cyclone separator. This here, hopefully it focuses okay. This here is a titanium part. It's an investment cast part at the bottom, which just provides the last part of, I guess, diffusion or whatever you want to call it. It's bonded into the carbon. You can see it there. As I said, this made it inside out, which is unusual. It's normally the other way, which is it's a rough surface, you know. But that's how they did it. So that's the main Cyclone. Very cool. Now, what you can see is there is two other Cyclones, which are here. There's two secondary Cyclones here and here, beside the main one. Now, what I can do is I can take off these. These were secondary parts that I cut off then, just access areas, which I'll take off now. That's one off. That's the other off. So hopefully that demonstrates the secondary Cyclones a bit better. Now again, this is the main input here from the pump. Just to show you that, so you can see what's going on. Now, these secondary Cyclones have a very important function, and that is, which I'll probably pause the video because it's getting a bit long now, and I just want to be able to edit them handier. They have a different function, which Honda realized later in the development program, of taking the compressed gases from the scavenge pump and separating that even further and giving a bit back to the engine. What I'm going to do now is, that's just before I stop the video, that's the output. So you can see that it's a titanium part again bonded in, and the layers, which hopefully will focus. The bulkheads. So what I'm going to do now is pause the video and give you a third video, or a third section in this video, of why these secondary Cyclones are needed. It's a very interesting discovery that they made, and I shall see you in a second. Alright, so the last section of the video, the third section, is just a better in-depth explanation, I guess, of the why the 2 other small cyclones were needed in the tank. So as I said, this is exactly what the scavenge pump looks like in the engine, in the Honda engine. Now there'd be what the sump is compartmentalized. In plan view, it's like that. In an 8-cylinder or an 8-cylinder, yeah, there'd be 4 compartments. There'd be two sharing, and each one has its own scavenge rotor, like that. Hopefully you can see all those. You can. So each one of those would have one scavenge rotor like that, which in a normal engine would be what's known as positive displacement, which means that when it rotates, it displaces a known amount of fluid. All right. So if this was the input here and this was the output, and this was blocked, it would break something, because it just can't compress the oil here, because due to the nature of, just take this out, hopefully, yeah, due to the nature of the timing of the input and the outlet ports, the timing is so that when I put this in here, it's hard to see it, but the way it's timed is that, if I just slide this in again, like so, the way it's timed, oh come on, like that. The way it's timed, it takes in the fluid, let's say on the bottom, it doesn't matter, or the top, takes in the fluid, compresses it, or not compresses it, just moves it to the top. All right, so you can see it there. These are around for years. So you can see as it passes the inlet and the outlet, it just moves the fluid from one to the other. All right. But Honda ran that system for years, and what they discovered was that the fact that the incoming, I guess, aerated mixture of oil and air could be compressed. So what they did was they changed the timing of the outlet ports and the inlet ports, which are, as you saw a minute ago, the 2, let's call them windows here. And they discovered that they could save a lot of horsepower. Like for every, no matter what happens, this has to rotate. All right. So no matter what's doing, this is rotating. So there's stiction here, there's losses, there's friction losses and all that. So it has to rotate no matter what. So what they discovered was they could actually change the timing of these windows here and here to actually compress what was going through the pump, which saved, I think, I don't know, like 15% of the losses of this pump. So they were compressing this mixture here because it was oil and air. Now, what they also discovered was, I just resort to the drawing board, I flip this over. So looking at the sump again, this is the crank. This is the dry sump here, and the oil collect here, and it has to exit out here in a port and into the pump, which is here. What they did for a long time was the oil would go up here and into the pump like that, into the scavenge rotors. Now this had a disadvantage in that it was only just sipping the mixture now and again, and it had problems sealing. It wasn't filling with oil all the time, and it was just not good. So what they did was they came up with another system, which is like so. sump again. And they put in a little catchment like that. So what happened was, this would fill with the oil, and it would always keep this pump primed. It was like a little tiny mini sump to keep the inlet primed. Okay, so that was a breakthrough in itself. Now, moving on from that and going back to compression, flip this one more time, hopefully the last time. So as mentioned, they discovered that they could compress the air oil mixture in this rotor, which saved, obviously for every turn it was the same amount of power, so they might as well compress it. But what they then discovered was, at certain times, now this is where the other two cyclones come in. This is going to get a bit complicated, but hopefully we should be okay. So this pump, this is plan view again. That's the engine, 1, 2, 3, 4. And the pumps will be off here to this side. Alright, so that's each scavenge section there. They'd be sucking oil from each compartment. Okay. They would then pump the oil into a secondary chamber here, driven again off the engine. This would be all in line, but I'm just giving it simple. This is the centrifuge, which is a propeller. Again, I mentioned earlier in the video, which should force the oil out to the side and the air out the middle. Now, what they discovered was, under some tracks or G-forces, this pump would suck 100% oil, which meant that it was no longer, what would I call it, had the room to be a, I guess, compress it, or it resorted back to a constant displacement pump, which meant that it would burst the pump internally if it wasn't able to compress the air, if there was no air in the mixture. So what they did was they put a redirect through all the chambers. So if it did find that it couldn't compress the mixture, the air oil mixture, it would redirect it out a second line into here. So it'll be like this. If I go across here into the tank, sorry, up here, and into two small cyclones, which you can see there. So that's why they were there. They were like a secondary main cyclone, but not used full time, only when certain parameters were, I guess, in place, or, you know, cornering or G's like that, where the pump wouldn't be sucking a, I think they came up with in the end, it was something like 60%, 40%, which would be oil and air. That's under normal conditions. But under certain conditions, it might go up to 80% oil, which this couldn't deal with, because it was set up geometry wise to just compress air and oil. So they had to redirect the solid volume, I guess. So that's why the second cyclones were needed. So that's kind of it, I think. Yeah, I think it is. Obviously you could write or read, you know, for 6 months about all this, but you know, short and sweet. It's a YouTube video just to show you the layers again. Something else. So these would have been made, just to finish off, luckily, oh yeah, I'll just split this. Hopefully you can see that there. Yeah. Luckily, due to work, about what, I don't know what, 5 or 6 years ago, I had the what would you call it? I guess lucky of being sent to China on a carbon fiber job, and I was sent to a very nice factory in Shenzhen, which I won't name just because he showed me around everywhere, but they made a lot of parts for motorbikes, for automotive and all that, and the owner of the factory showed me how to make nearly all the parts, you know, that were inconceivable at the time to me. But just to go through these parts, how these will be made. These will be made with a silicon mandrel, which would be like a rubber shape of the parts you need, and the carbon fiber was then laid up around them like that, and taped with heat sensitive tape, which would shrink when it was put in the autoclave. So these would be made in silicon, wrapped with carbon, wrapped with tape, put in the autoclave, and the tape then would tighten the carbon around the silicon mold, which is how you can see it's shiny inside there. Hopefully you can see that. Yeah. So you can see it's all shiny inside. Now that's bonded there, but that's all right. But once it was cured, then you could remove the tape and pull out the silicon mold out of the center, and the ways were all formed, whatever you want to call it. But it was very cool to see all the process. That's, you know, that's why I know a good bit about carbon layup or whatever. This would be all cut on an ultrasonic CNC laser machine, where the cloth would be laid down just out of the freezer, laid down, and an ultrasonic knife would cut it all out, and then they'd be laid up to a layout plan or whatever like that. Very cool and extremely light. I mean, you can literally, it's nothing, you know. But that's that. So I hope you like this video. I hope to get another one up tomorrow. It's what, I think it's about 2 a.m. now, or 2:30 a.m. So apologies if I sound a bit tired, but it was better to get out a video, I think, than not. It's been a while, and I want to get back at it again because I've a lot to show you. So yeah, that's it. Thanks for watching. Good luck.